Good evening all, and I'm happy to see a lot of crowd during this Sunday evening, and it's really great to start the session. And it's my privilege to start my session, and I'm completely going to give you an insight on automated machine learning, or also called as AutoML. And this is a short bio about me. To show any such demo, so it's not going to be a big deal. And if there is any inaccuracy in my talk or in my content or in my presentation, it does not reflect with my lab or with my university. It's up to me, and whatever the opinion I'm just going to share with you is completely related to my thoughts, and it's not pinpointing or pointing someone else. So this is a general disclaimer of my talk. And before starting or before going for the complete agenda, I just want to share with you and start this particular talk with this particular problem. Uh, uh, I want some interaction from the audience side. I'm depicting some pictures here in my slides. What you are able to see it, and what can you conclude what exactly it is, what I'm trying to show you? uh, it would be great even if you just drop in the chat. So I think chat is enabled. Okay, you want me to go in slideshow? Okay, fine. Yeah, is that fine now? So if I go in slideshow, I couldn't able to see the chat, and again I couldn't go for a complete interaction. So that's the reason I'm just asking. I'm just not going for a slideshow, because since it's an online meeting, you can magnify it, right? So I feel more comfortable when I am not in the slideshow. Shall I? Sorry for that. Yeah. So it would be great if someone answer me for this question. So what exactly the image is conveying? Any idea? So what exactly this image is? So it's a airship. Okay, that's a good answer. So actually, it's a fighter plane, right? So it's a fighter plane, and this images whatever, yeah, plane under attack. Okay, great. So whatever the image which I'm displaying here, right? It's completely a DALI model, which got which completely generated it, right? So the thing is, again, I used Bing for doing the same for generation, right? So when I queried for a fighter plane with bullet holes, so this is what it generated. So I am just depicting it to you. So why I want to start my talk with this particular problem, right? So there was a very interesting problem, which was in a huge race in data science community. So the problem is finding the missing bullet holes problem. So how many of you aware of this problem? I just want to know about the count, because since this is completely on data science and the tools, so I would like to emphasize why data is very important. That's the reason I took this particular problem, right? So most of my session, I just want to cover it in a practical aspect. I just want to teach you one low code and no code. So just be quick so that I focus more on real time demonstration. So just be quick. I just want to complete the theory as soon as possible. So I thought I want to complete it before 7:30 or 7:40. So I want a quick interaction from the audience so that it will be going very lively. So when you are seeing, okay, let me dissect the problem. Okay, so when you are looking at this, so I just depicted the image and I gave you a clue that it's a fighter planes, and the fighter planes. And when you look at this particular scenario, right, it's not a modern plane. So it's a very old plane. So these planes were used in World War II, right? So these, when you look at this particular image, right? So it's a fighter plane, and there are some dots in red in color. So what these dots are denoting? So these dots are denoting the bullet holes which hit the particular planes. So why this particular problem statement is, or this particular scenario is very important is, so this use case is one of the very important use case for why the data interpretation is very, very important. So now what happened was, so during World War II, the planes and the attack through air caused a collateral damage. So what they want is, almost all the countries wants to go for air-based attacks. So because it is making collateral damage rather than sending the troops. So what they want is, they want to build the aircraft. So they want to build the next gen aircraft. So what they want is, they want to know which are the parts they want to armor it. So, and when you look at the scenario of World War II, it happened in the late of 1900 something, in and around. I'm weak at years, so if there is any inaccuracy in my terminology in terms of pinpointing the year, sorry for that. So you just assume on which particular year. At least it will be 70 to 80 years back minimum, right? So what happens was, during that scenario, so the planes were not as modern as what we are having, right? So what were the engines and other things? So it was just a turbulent engine, and again they can carry only the limited number of weights. So what they want is, they want to design a next gen aircrafts, so which can have a better armor, so that it can withstand, or it can be resilient during the enemy attack. That is what one of the primary objective, and they want to design the next gen aircraft. So for that, what they did was, they collected the data from the planes which got returned from the battle to the airbase. So what they did was, they called the scientists, data, the mathematicians and the statistician. Then what they did was, they collected all the data. So all the data finally they collected from all the planes. Then they plotted it on a particular diagram. That's what the diagram is depicted here. And if I ask you a question, so which are the parts, on seeing this particular image and the bullet holes, which are the parts which has to armored? Because again, you think twice. So when I'm stating armor, so it should be lightweight and it should not overload the plane. If we overload the plane cannot carry the payload. So the ultimate goal of the fighter plane is to carry the load. That is very, very important, right? So what could be the possible places? So what they did was, the scientists, what they come up with the conclusion was, so yeah, so I got an answer from Mani Deepak. That's great. Left, right wing. Okay, that's great. So which means what the mathematicians and the scientists concluded was, wherever there was a bullet holes, they said they want to armor those area, so that the plane can withstand during the attack situation. So now again, the main data what you want to interpret is, so where the data, you can able to see the engine part, and the connector of the left wing, connector of the right wing, and the connector of the rear wing, right? So these areas are not at all having any bullet holes, which means, again, you have to remember what I said before. So what I said before, so they collected the entire data and they plotted based on the planes which were returned from the battle which were returned from the battle to the base, right? So, and again, the interpretation here was the plane which got hit with the bullets on this area, the engine area, or on the connector of the right wing or a left wing or a tail, right, or a rear, right? Those planes never return to the base. That is what the conclusion. So now, whenever you want to create a armor, you should not create a armor on the place where the bullet holes are, because already those areas can withstand. That's what the proof, and you have the plane which got returned from the battle, right? So finally, one scientist who gave the contradictory valid statement was Abraham Wald. So he's the one who concluded that the place where there is no bullet holes has to be armored. That is what the final conclusion. The interpretation of the other scientist got completely wrong, and finally they made the next gen aircraft. So now you hope you understand so why data and interpretation of data is very, very important in data science. I'm not concluding with respect to a particular application domain or anything. So why the interpretation of data is very important. This is what the use case I just want to start with, and it's really great. So I hope all of you understand the impact of data interpretation, right? And let us start with the today's session. So AutoML. So the main goal why I selected this particular topic is basically when you might have wondered. So when some professor read my profile, and most of my research area are completely on. I'm not audible. Oh, really?
So you are audible.
No, sir, you're audible.
Um. Okay. So, but I got some message. Oh.
It
Okay.
might be at their end.
Okay. Fine. So, why I selected this particular topic for delivering my talk to all the audience was when the other professor read my profile. Most of my research is completely on cybersecurity, right? So I'm not a ML guy. I'm not a data science guy, but I know the application domain and the applicability of how the model work. And since we are doing a lot of research on AI based, data science based, and other things, but we completely use a no code, low code platform where we work only on applicable AI. So one of the example is I just showed you these are all the bots, right? So this is one of our current research which we are currently working on, and we are making it into a autonomous module. And this is India's first academic 3D printed humanoid, which we built 6 years back. In 2018, we built this entire humanoid. I think so, right? I just remember in between 2018 to 2019. So it has a vision, and it can replicate the human action, and again it can also go for crowd surveillance, facial recognition. So it has interfaced with a different set of APIs which has been exposed. And again, because since this particular humanoid has a low and resource constrained devices like Pi and Nervo boards, it cannot go for a bigger computation. And 2018, there was no YOLO. Only mask RCNN was the recent object detection model at the time. So we implemented mask RCNN, but it's a heavyweight. So what we did was we just pushed everything as an API and we exposed it. And finally, only it renders, it captures the image and sends back and get the response back, and it just exhibits. This is how we handled the entire scenario of the entire automation for the entire robot. And finally, we made an operating system as well, right? So so as being a cybersecurity guy, so I focus more on low code, no code platforms. On the AutoML does the same, right? So it completely goes with the complete methodology and process to make ML available for a non-ML expert. That is the beauty of this AutoML platform. So you don't need to have a ML knowledge, and you don't need to have a data science knowledge. Nothing. So what it does is you ingest the data. So the machine itself, it takes automatically how to pre-process it and how to process it, and finally it gives you a result. And even if you're not satisfied with the result, you can again fine tune it. That is the beauty of AutoML. And again, so the current cloud platforms, like almost you take all the key players like Azure, AWS, or the local vendors like E2E. So they have their own pipeline for AutoML. So you can do a lot of wonders. It does not require much knowledge. Just you need to have a basic computer science knowledge. That's enough. You can do AutoML with 1 or 2 clicks. So that's what I'm just going to demonstrate you now, right? So this is the agenda of my talk. So first, I'll be covering what is meant by AutoML, and then why AutoML, and how to provision ML pipeline, and what is the difference between a DevOps and DataOps, and how the evolution goes with ML Ops, and then we'll go for a demonstration with one no-code, low-code platform, and we can build the entire ML pipeline, and we can go for deployment of that as well, right? And this is the current trend of AutoML over the current period, right? So the AutoML trend is still getting raised, and this is complete information from Google Trends source. And even you can go for regional specific. So as per the current situation, a lot of Indian developers are moving towards AutoML, and that's really happy to see. And let us start with the basics of ML and what could be the possible ML steps involved, right? So the first thing, when you take any ML model, so the first major part is gathering data. So once you gather data, so gathering data is not a big challenge, but the second part, so preparing the data is very, very important. So here comes the role of a data scientist, right? So it hardly requires how to interpret the data, and finally you have to prepare the data so that your model can give you a better result. Otherwise it will go for unbiased, it will go for completely biased or error, or either you can go with overfit or underfit, right? So a lot of problems can occur, right? And data imbalancing problem, and it leads to different set of problems, right? So preparing of data is very important, and then you have to select the appropriate model. That is also one of the main step in ML. And finally you have to go for training, and finally you have to go for validation. And then if you are not satisfactory with your current performance of your model, then you can go for hyperparameter tuning, and finally it can yield some result, right? So this is what the 7 steps, right? So you can ask me a question. So even Google, if you search in Google, right, so it will you can just take any data, or you can just download any data, and you just go for Google and search the basic any CNN notebook. It will give you the notebook, right? So when you are fitting those notebook with your data, hardly you can achieve 80% of accuracy. That is not a big deal. Anyone can do it. Just your programming knowledge is enough. But what happens is, so above 80 to 99%, that is what the industrial grade results, right? So for achieving that, you need to have a deeper insight of all the data science and other things. So it includes ETL tools as well, right? So that we'll be seeing how it is happening, and how it is possible with the AutoML, right? So this is what the current reality of ML, as I said you, right? So whenever you are you want to go for build your own model, so you should have appropriate training data. So it should be balanced. So it has a set of condition. It should be balanced, and again it should be properly pre-processed. And for doing all these things, you need a data scientist. That is very, very important. And then you have to go for your trained model, and finally you validate with your test data. Finally it yields some answer. So this is what the reality of an ML model. But this data scientist, right? So this particular guy incurs a huge cost for any organization. That is very important point which you have to notice here. And the main goal here is, so we are just completely going to remove this particular guy from this particular block, and we are going to put our AutoML model, so which automatically takes and interpret the data based on the data with the user given. So it selects the model and it recommends the model, right? That's the beauty of AutoML. And finally, based upon the recommendation, you can go and it can give you a better result, right? So you can ask me a question. So even if humans are doing, so how automation can do it? That's the beauty, and that's how they build it. The current low code platforms which is available on, you take Azure, any ML Web Studio or AWS. So almost everything is having the same thing, right? So this is what our ultimate goal is, and again we'll see how to achieve all these things. And when we are talking about the workflow of the traditional ML training, and again auto ML training workflow, right? So when you go for a traditional ML based model, first you have to define a problem, and then you have to go for the data collection and pre-process the data and train the model, and finally you go for evaluation. This is how it goes. And one more hard fact is labeling. The labeling part of your data, this phase, the collection phase, that is very, very, very challenging part. That is really very, very challenging part. And then you have to go for complete pre-processing, right? So even your how much bigger labels you just think. So how many objects are there, right? So even in olden days, I do remember Amazon was giving it for crowdsourcing, and they funded. So if you label for 100 image, they pay you some certain rupees. That's how they collected all the labels from the user, just by crowdsourcing. And then finally they built their own entire thing. So whatever you are seeing currently with all your tech part, right? So either in Google, or Google automatically dissects the face, and Facebook dissects the face, and it just puts the separate folders, right? So how those things are happening, because everything was your previous labeled work only, right? And when it comes for the AutoML workflow, so all you need is just you focus on defining the problem, collect the data, and give it to AutoML. So you can think that it could be a black box. Obviously, it could be a black box. And if you want to design your own, there is a provision for it. You can go for it. Or else, whatever the recommendation the model is going, whatever the recommendation the engine is going to provide, that itself it's better. That's what I'm trying to conclude, right? So how it got refined? You just think you should have a problem, collect the data, and finally you can go for giving it to AutoML, right? So you can ask me a question. So okay, I collect the data. So how my machine knows it? Because being a human, we knows that these are all the objects, and we have our previous knowledge, right, of labeling, because it was already taught to us and it was on our neural. And finally, we just retrieve back and we are exhibiting. But what happens when it comes for a machine, right? So just by collecting the data and just giving it, how the machine knows it, how the machine labels it. Without label, you can't go for a model for classification, because you have to pinpoint it, because it's not having a human intelligence, right? So that is the beauty of AutoML. So I'll also show you how the auto labeling works, and how automatically they are doing it, right, with some sample use case I'll be demonstrating. And when it comes for the other workflow, right? So the machine learning development flow and other things, right? So the conventional development goes with data collection, as I said you before. So then it goes for data pre-processing. Then it takes the appropriate features, right? So feature engineering itself, it's one of the art. So selecting and defining the total number of feature which has to be extracted, and then out of all the features, there will be a significant feature which gives a more accuracy and it impacts the performance of a model. So those features has to be selected. That is also one of the major part, right? So there comes the feature selection, and again algorithm selection, and based on the evaluation report, then you can go for tuning your hyperparameter, and finally you can go for model, and then you can go for deployment. That's how it goes, right? So these are all some of the machine learning development flow. And when it comes for the automation of the ML ops workflow, right? So this is a sample thing. I just want to depict you with one of the pictorial thing. Just a minute, I'll just open it. Yeah, so this is the whole pipeline of MLOps, right? So, and again, if you look at here, right? So the first thing, data sources, right? So it could be a structured, or it could be unstructured. I hope my video screen is visible to you. Can someone acknowledge me? Is my video screen is visible, or just an image? Yeah. So now if you look at the MLOps pipeline, right? So you have a data source. The data source can be structured or unstructured or semi-structured. You don't need to worry about the data source. And you can ask me a question. So how this data source, which can have a structured or semi-structured or unstructured, it could be any of your DB, right? So there are a lot of DBs which supports all these things. A typical example is you can go with a Firebase, or you can go with elastic based things. Elk is there, right? So, and again, once you have a data source, then you can go for batch wise data ingestion, and you can have a data lake here. So the data lake can be a distributed database or anything. And finally you can go for a data pipeline. So here comes the data ops, so where you pre-process your data and you put it in a pipeline where it goes with CI/CD, complete continuous integration and continuous deployment, right? So once it is done, then it goes for a feature engineering phase, where the feature engineering phase, you select the feature, you extract the feature, and then you select the feature, appropriate feature, which can increase the model's performance. And then you can go for a model development. So here you go with train, validate, and finally you evaluate, and you can also have a particular engine for monitoring your model development. And once you get the appropriate accuracy, well, let us take the performance parameter as accuracy. So, or the model converges at one particular point where you achieve the maximum accuracy, you go for monitoring, stop there, and then you go for model deployment. And finally, even if you are going for a model deployment, you can bundle the entire model as a package, and you can ship it using a container. Or if you have a multiple chain of models has to be deployed, you can go with other deployment engines or automated container deployment engines like Cube. That is also possible. I think during my last week talk, my students Arvind and Devi Priya ma'am covered the whole aspect of how Dockers can be used for shipping and deploying a particular application program. Once you go for a model deployment, then you can serve those model deployment either as a API. So API, once it goes with the API, you can consume the API with any of your application. It could be a web app, or it could be a mobile app, or anything. A typical example I just want to share with you is, so this is one of our face recognition API, which has been deployed with the same scenario, right? So for accessing this particular API, we have a separate mobile app called Mukam. So you can just search it in App Store, right? You can find an app called Mukam, and it's basically a facial recognition application, right? So the same thing was exposed here. So whatever I just explaining you here, right? So how it is getting served, right? The same thing I was just about to show here. So that's how the user is going to enjoy the entire pipeline of your MLOps, right? So, and again, when you take the components of uh, the total MLOps, right? So, sorry, I'll just go for, yeah. So when you take the components of, oh, just a minute. Yeah, this doc is just disturbing me. Yes, yeah. So when you go for the components of DataOps, particularly in MLOps workflow, right? So when you take the total MLOps workflow, so the entire chain goes with the MLOps workflow. That's how it has been shown here, right? So if you look at here, right? So the entire explanation which I gave you with the entire data flow, right? So the same thing was given here as a architectural block, right? So the entire thing, right? So starting from your data ingestion to data transformation and how to prepare the data, and it includes your data versioning and metadata information as well. And finally, it goes with model training and model validation. The entire process of execution goes with continuous integration and continuous deployment. That's how it gets orchestrated, right? And finally, it goes for the production environment, and finally it gets served as either a API to the user via any of the app. It could be a web or it could be a mobile. And again, you can ask me a question. So how this DevOps, DataOps, and MLOps is going to create a agile, right? So when you go for a DevOps platform, right? So you whenever you go or whenever you start a code part, right? So let us take a software. So a software could be a ML or a ML model, right? So anything goes with a plan, right? So that's how it has been taught, and it has been documented, the entire software engineering process, right? Plan, code, build, test, and finally you go for releasing, right? So until this test phase, it goes with all the debugs, and once it gets completed, then you go for release, and finally you go for deploy, operate, and finally you go for monitoring. And this entire process is a interconnected process. It goes with complete CI/CD based operation. And when it comes for a data ops, right, the same process will happen, but it goes with the data observability. So how the data observability goes? So it starts from the entire pipeline, starting from the ingestion state to visualization state, right? So a typical example is you can go with a lot of monitoring tools, starting from data ingestion. So you can automate here the data transformation, because it was all the process, whatever it is happening here, right? So it was a common process, right? So once you have a robust engine, you can select and you can create a complete pipeline, and finally you can go for, if you need any change, you can go for complete CI/CD process. That also it is going to support, right? So, and again, when it comes for MLOps, so the broader aspect in terms of theoretical, you go for design, model development, and finally it goes for operation, right? So this is how it works. And when it comes for auto ML, right? So all these process all together, how it is going to help in building the auto ML platform. That's what we are going to cover now, right? So because when it comes for MLOps takes care of the entire automation of building, deploying, and it also focus more on scalability and other things. Whereas in auto ML, it focus more on data part and model selection part and deployment part. So indirectly, the backend behind the auto ML was MLOps only, right? So MLOps could be a subset. So that's the reason we covered the MLOps before we start with auto ML, right? So when you are talking about the auto ML part, right? So as I said you before, so auto ML, it completely accelerate or improved efficiency for, and it will be available for non-ML experts as well. So that is what the main context of your auto ML. And this auto ML also has some set and some steps to follow, right? So how we built a basic ML model. So likewise, we also follow some sets for some proper hierarchical steps for building the auto ML model as well. So first thing, identifying the problem, that is very, very important. And second thing, you it is very, very important part. So whether you are going to go for coding or you are going for a no code platform, that is very, very important. So because all the no code low code platform has a support for building your own ML model, that is one of the important thing. And finally, you have to specify the source of labeled training data. That is very, very important. If not labeled, then you have to go for labeling your own data. And finally, you have to configure your entire ML engine. It includes parameter as well. And finally, you submit the job for training, and the training takes place automatically. And finally, you can go for reviewing the result, right? And when you look deeper into why you need a auto ML, right? So so the major problem with the machine learning model is the machine learning models should have expertise in data science domain. That is very, very important. So either it could be your domain expertise or it could be a mathematical expertise. Whereas this auto ML does not require any of the particular part of data scientist, right? So on this particular auto ML completely reduces the bias and errors, right? So which occurs mainly when we are designing our own ML model. That is very, very important thing, right? So and again, any organization can easily go with auto ML because it's a complete engine which is available, and you can just push your data, get the result. It's a very simple job, right? You don't need to hire any of the data scientists who are so-called industry experts, right? And again, most of the time, this particular auto ML reduces the maximum amount of time in doing the routine jobs, like data pre-processing step. That is one of the major step which is completely handled by this auto ML. And again, model recommendation is also one of the aspect, right? So this is all about the theoretical explanation of AutoML, and let us start with the real-time one low code no code platform. So just acknowledge me, is my browser visible? Just acknowledge me, is my browser visible? Okay, no, my browser is not visible. Okay, I'll stop here. Now can you? Can someone acknowledge me? Is my browser visible?
Yes,
Okay.
sir, it is visible.
Okay, perfect. Right. So now, when you, okay, I'm just going to handle the entire pipeline with a platform called Edge Impulse, right? So the first thing is, whenever it's just a free platform, right? So whenever you sign up, you finally land in this particular dashboard, right? So first thing is, as I said, it's a complete low code, no code platform. So where it has a support for creating your own ML block also. That is what it is given here. Custom ML block, you can create your own ML block, right? Or else I'm just a other domain guy. I just want to interpret my data and I want to check the results of how the machine learns. Just you don't need to worry. So this is the right platform for you. And just create a new project. Click on this particular button. So once you click on this particular button, it will ask you to enter the project name, right? So basically, this is a free platform. So it gives you a 20-minute job limit. So if you utilize a GPU, right? So Tirupati sir, shall I complete this? Then I can answer your question. Is that okay? So you asked what is the difference between a traditional ML and auto ML. So when you go for a traditional ML, you have to, from the data handling part to deployment, you have to take care. So data processing, data pre-processing, so data labeling, it includes labeling also, right? So the entire data part or data pipeline you have to take care, and finally you have to select the model and you have to deploy the model. So this entire workflow has to be done manually. That's a traditional machine learning. When it comes for AutoML, you don't need to worry about anything. Collect the data. Once you have the appropriate data, give it to the engine will take care of entire thing. Finally you validate the result. This is what the basic difference between a conventional ML and AutoML. Automatically the entire pipeline will be taken care by your engine itself. Is that okay? Is that clear? Okay, so now let us create a sample name, SRM demo. Okay, so I'm just going to create a project name called SRM demo, and I'm not going for enterprise edition. I'm just going for a developer edition. So let me go for creating a new project, right? So I'm done with my creation. Once your project gets created, so you can able to see the interface exactly like this, right? So now when it comes for a getting started phase, you can have a particular tab to add your existing data, or you can collect the data, or you can upload your own model. That is also possible with this, and it has a support for taking or connecting any of your camera sensors, like your mobile phone can be connected easily, and you can go use that particular mobile phone camera sensors for data collection. That much reliable and flexible this particular platform is. And again, if you look at down, right, you can able to see a particular info called project info. So it goes with a particular terminology called labeling method. So because labeling method is one of the important aspect you have to focus. So it has two. One is one label per data item. So which means, so you can have a single object on an image, and you can go for complete capturing and you can use it. Otherwise, you can go for bounding box based. If you are going for bounding box based, you have to select it, or else you can give it to auto labeling methods, which is available here as well. So now I'll be explaining you that. So let me complete the entire pipeline, and I'll show you how easy for me to deploy a basic object detection model live now. and again you can able to see the target device. So the target device, you can go with any of your, even you can, it has a support for Arduino and other things as well. So you can go with the low end devices as well. You can go for deployment and you can test it. So I'm going for a Cortex M4 F8MH because my mobile is a Cortex, having a Cortex processor. So I'm going with this particular target device. That's how I configured, and by default it is on the same as well. Okay, so now as we saw here, right? So the dashboard, I think I have explained you, and other hyperparameters I just want to inform you is, you can either use your GPU for training. So if you enable it, that 20 minutes will start here, right? So if you want, you can go with enterprise performance also, but they will charge you, right? So, and the job limit by default, it will be on 20, and a training job memory size, and the other file size is also given here. And these are all some of your other hyperparameter. So the train and test split. So train and test split, from your data automatically this particular engine will take care. Or else if you want to have your own custom, you can modify here. I'm not going to touch any of these things. So let me go with the current one, right? So now what I'm going to do is, I'm just going to do a data collection part, right? So shall I open my camera? Just a minute. Right? So now what I'm going to do is, I'm just going to use one of my devices for data collection, right? So it is showing me no devices connected. So let me go for dashboard, right? So still it is showing me no device connected. So if I want to go for data collection, I can click on collect data. Once I click on collect data, automatically it gives me an interface. So it is asking me to connect to my computer or to my local onboard. That is also possible. Or you can scan your QR with your phone. That is also possible, right? So can you able to see the whole thing? So scan QR code to connect to my phone, right? So now what I'm going to do is, let me do one thing. So I'll just scan it. Yeah, I'll just yeah, I'll just trigger the scanner on my mobile phone. Yes. Yeah, so now you can able to see, my phone got connected. My phone got connected, right? So uh, can you is it visible? Can someone acknowledge me? Okay. Yeah, perfect. So now my phone got connected, so I can add my data for the entire object detection, which I want to do it live. So automatically you can able to see my phone ID has been given here, and you can give the label name, and you can use any of your sensor here. So from my phone, it is asking me to take any of my value. So either you can go with accelerometer sensor, microphone, camera, or positional, whatever it is, it's up to you. You can go with it, right? So now I'm not going to touch this particular part. So then I'll come to data acquisition part, right? So the data acquisition part was what exactly I was saying you now. So now let us start collecting the data. So now, okay, just a minute. So now what I'm going to do is, I'm just going to collect the data from my phone, and that particular data will be added here, right? So that's what I'm going to do now. So what I'll be doing is, I'm just going to collect a few images, right? So let us take, I was in my room. I have my AC remote here. I'll just classify few objects here, or else I just give me a minute. I'll take some fruits here. Let us go with multi-class classification. Just a minute. Yeah, am I audible? Can someone acknowledge me? Am I audible? Okay, perfect. So now I'll be starting my data collection part. Yes. So what I'm doing is I'm just going to, I have 4 different objects. One is my AC remote. I took Line King dates, Cerlac packet, and then Ashirvad vermicell. That's what we are going to do now. So first thing I'll be collecting with my AC remote, right? So I'm just giving a label AC remote, and then I'm capturing it. I just started capturing. So can you able to see here? So you got the data here now, the raw data here now. Can you? Yes. Now I'll be collecting here. So you can able to see here the timestamp also. You can validate the timestamp also. Just now I'm collecting. So I'm just taking some additional good samples here. Totally I collected 21 items. I'm just going to click some more items. At least 100 items per 100 samples per item. Let us collect. 71. 90. I think 100. 1, 2, 3, 4. Yes. Okay. So now we successfully collected 100 items for AC remote. Okay. So now what I'll be doing is I'm just collecting for line dates. So now I started for line dates. Okay. Okay. So I got 100 samples for line dates. So now I'll go for select. So you can see the line dates image also. Yes. So now I'll go for select. Okay. So Cerlac also I collected 72 items. So let us go with some imbalanced data set. So then Ashirvad vermicell. Okay. So I'm just going for Ashirvad vermicell. Yes. Okay. So I think I am done with my data collection. So here, yes. So here, Ashirvad vermicell and the other one, so Cerlac, so which has imbalances in the data set. Okay. So now you can able to see the data here. So now let us go for data explorer. So once you click on the data explorer, so it is asking for something for me to select, right? So automatically you can able to see only one option available because you can able to see here. So this gives me my ML engine, auto ML engine gives me a recommendation that this is great for my most of my image classification project. Okay, let me click on it. So dimensionality reduction, either you can select a SNE, which is going to be a standard, or you can select a PCA. But according to my data set, it recommends me with this particular dimensionality reduction technique, right? So then I can go for generating the data explorer. So now it will take some time because it depends on my data cluster. So automatically the entire process, what I have explained you in the data ops, that engine, that will be completely taken care by this particular engine. So you can able to see here. So it started creating my windows for 3 classes. So Ashirvad vermicell 43, AC remote 100, Cerlac 72, line dates 100. right? Automatically it creates and build the entire embedding. So the entire process will be taken care. So not only the data ops, once the data ops is completed, then it takes care of the ML ops as well. Finally, even if you add new data, it will go for CI/CD. That is what the beauty of AutoML. So now, so my data explorer got completed. See how wonderfully it is giving me the entire results, right? So automatically my data explorer gives me a whole results, right? So it's really a cool one, right? I'm now whatever I'm doing is a live one. I'm not taking any of the data set, nothing. I'm just doing everything on the live, right? So then now my data part is over. So then I have to go for my model design, right? So when you go for a model design, so now my data part is completed. Now I have to go for a processing block. So now let me click on the processing block. Now it gives me a recommendation. So for if you're going for an image, you go with this, or else you can select with the other recommendation also. So here if it is an image, the processing block, you can go with pre-process and normalize your image data. Either you can go with, because this is what the recommendation is, right? So or else you can select any other thing also. Raw data is also there, so you can select raw data, or you can go for audio or anything. It depends on your data, you can select. So since it's I'm going with only the recommended one, so let me add it. So I'm not going with any other things. I'm just doing whatever the AutoML block is giving me as a recommendation. I'm not doing any fantasy things, right? So now my image block, pre-processing block has been added. So now I have to build my model, right? So here comes the learning part, right? So now I'll click on a learning block, and again automatically you can able to see the recommendation was my transfer learning model, right? So you can go with any of your transfer learning model, or if you want to classify, you can go with classification, or else you can click on this show all blocks. Anyway, it gives you a complete information about it. So how you can go with it, right? Object detection you can go, classification you can go, anomaly detection you can go, transfer learning also you can go. So right, so now I'm just going to go with the recommended one. So because this model is recommended by my engine, right? I'm just adding it, and automatically the output feature has been computed, because it automatically the data explorer has labeled it. That's how it is showing me that this feature has been, this is going to be the output features. So now let me save the impulse. Yes, my impulse has been saved. So once your step is correct, you can able to see the green light here. So then I can come to image block. In the image block, you can able to see all the labels here, right? So now what I'm going to do is I'm just going to save the parameter, and once it is done, my parameter has been saved. Then I'm going to generate the feature out of it. So again, this process, the feature block, right? So this is also a part of your data ops that I have explained you before. So this data ops will take care of your feature and feature engineering as well, right? So that will be taken care, and it will take some time, but not bigger time, because I'm not using a GPU. Again, remember, I'm just going to use only I'm just using the CPU. I'm not going to use a GPU one. If you select GPU, it will be very fast, right? But even these problems does not require a GPU for computation. Yeah, once my feature generation is completed, you can able to see the feature explorer very clearly. So you can able to see the feature. These are all the computed one with reduced feature. And again, finally, you can able to see on device performance also. Hope you remember in the first block in the dashboard, I showed you which device I'm targeting. So this is the processing time which it gets executed, and the maximum peak RAM usage for this particular model deployment is only 4 KB. It's not going to exit that much quantized output. You can get it. That's what again I succeeded in this image block also. Then I go for a learning part, right? Sharanya ma'am, I just need access to my mobile, ma'am, so that I can show them lively. Saranya ma'am, I just need access to my mobile also. Ma'am, I'm giving my ma'am. Is it okay if I give my same ID? Ma'am. Okay. Okay. So until okay. So what I'll do is ma'am, I'm just giving my same ID. You can just approve me. I'm just joining as a guest. Okay. Okay, ma'am. So okay, let us. I think they have given me access to share the content. Okay, let it be. So fine. So now let us come to the transfer learning block. So this is where your neural network settings will be, right? So these things are by default, the hyperparameter and the entire hyperparameter tuning and the other part will be automatically taken care. So that's the reason it was like this, right? And again, it also supports a particular phase called data augmentation. So hope you remember so the Cerlac, the first class AC remote was 100 sample, second class line dates was 100 sample, Nestle Cerlac was just 70 sample, Vermicell, acid Vermicell was just 50 samples, right? The class is not balanced, but automatically if I give auto data augmentation, so the model will take care the entire augmentation part. So this, when you are clicking on this, automatically the data augmentation part will also be taken care by your neural network model, right? So now you can able to see the input layer feature. And again, yeah, so this is one of the major part I just want to show you here, right? So based on my data, there is a recommendation from my AutoML engine that MobileNet V2 version is going to help me, right? Or else if I want to overload, I can select a different model. So these many models are available, but my recommendation was MobileNet V2 version, right? So these many recommendation were given to me, but the optimal one which the engine suggests me is V2 version. So now I'm just going to train it. So whatever the process which I am explaining you and I'm showing you live, right? So these things, when you are doing it manually, takes several hours. Literally, it will take several hours for sure. So now it will go for multiple iteration, right? So that's what it is showing, right? So the epoch states the total number of iteration taken for the entire training process, right? So that will also be automated. So once the training is completed, again it will give you the validation results also. So it will plot a confusion matrix and it will give you a clear picture, right? So from here, if you want, you can backtrack and you can go for you can go for other model selection also if you're willing, or else if you are satisfied with the existing result, if you are satisfied with the existing result, you can go with the satisfied existing one as well, right? So the recommended one. See, it is doing a conversion from TensorFlow Lite Float 32 model. So when you do it manually for this conversion and going for deployment itself is a big challenge. But here we are doing it with a single few, not a single click, just with a few clicks, we are going for a real-time deployment. That is what the beauty of AutoML, right? And you don't need to have a ML knowledge or data science knowledge for it. Again, I'm repeating the same. Yes, again it is converting for INT 8 also. So these two are optimal model because you can deploy it, even it has a support for deploying it in Arduino, right? So those Arduino boards are very lightweight, right? So limited or resource constraint you can call it as, right? So for that, you need a reduced quantized thing. So that's what it is converting to as much as possible. So it will take some time because it's we are using only the CPU power, right? Not GPU one. So that's the reason. Yes. So Saranya ma'am, did you give access to my mobile device?
Sir, in order to do that, sorry about that. I was not the co-host earlier. So two other people have been the co-host, so I was not able to answer. So with respect to that, what should be done? Like, can we,
Okay.
Mega, can you just tell me
You
like,
want to join with your mobile phone, is that it?
Yeah, so that I can show you lively how the deployment goes from my mobile device.
So you can log in from the same ID.
No, ma'am, but I want to share my screen. Is it possible for me to share?
For to do two screen sharings at the same time, I don't think it is possible, sir.
you can
Okay,
just
ma'am.
log
What I'll
off
do is I'll
with your
stop here and I'll show my
system for a
screen.
minute, sir.
Okay,
I
ma'am.
think
Sure.
you can just leave the meeting from the system and join through the mobile and then
No,
present from
I
your.
think it is possible for you to stay connected on your laptop now and log in from your mobile at the same time.
Ma'am, that's the reason I use the same credential, but let me check it out. If not, okay,
Okay, sir.
somehow I'll try to manage.
Okay, sir. Thank you.
It's like a second thought, like because uh, a presentation from the mobile login, like when we are just logging in through a mobile, Cisco doesn't allow us to actually present our screen.
I
So
understand. Okay.
just try anyways.
Okay, ma'am. So I'll try to, or else, just a minute. I'll share my whole screen, or else I'll use my other Teams to do that. Teams can work. I'll drop from my mobile and I'll do it with my Teams. Ma'am, is my Teams screen visible?
Like it's got something like grayscale area, like something that's actually seeing.
Okay.
The browser is visible now.
Okay, browser is visible. Okay, ma'am, fine. So, okay, let me check it out. So, meanwhile, I'll explain. So, now my training part is completed. So, you can able to see the entire model performance here, right? So, how beautiful it is, right? So, it gives me a complete confusion matrix of my validation set, right? It's perfect. You can be able to see the beauty of accuracy, and the loss was what almost we are done, right? So this is more than enough for a basic computation. That is really cool, right? So now what I'm going to do is, with all these things, I'm going for a live classification, right? So it's showing me for no device connected. Okay, so let me click on deployment. Yes. Okay, sorry. Right. So in deployment, it is asking me for launch in the browser. So now what I'll do is I'll just stop and I'll share my whole screen. Yes. Yeah. Is my whole screen visible?
Yes, sir.
Yeah, perfect. So now if you look at here, right? So now I'm going for deploying the currently created model on my mobile. So now what I'll be doing is I'll be sharing my mobile screen. Okay, so is my mobile screen visible? Ma'am, is my mobile screen visible? Sorry, is my Teams visible
Yes,
in
sir.
the left side?
Yes,
Yes,
sir.
sir. Yes, sir. It's
Okay,
visible.
perfect. So now I'll go for a scanner. I'm just going for scanning. Okay, sorry. So now I'm just going for scanning the QR code. So there will be some jitter because the response will be a bit slow. So now my model deployment is going on my mobile device. So if you look at here, right, you as I was stressing on continuous integration and continuous deployment, right, you can able to see during your classification also, live classification also, you can go for data collection as well. You can switch quickly, and then this can also be pipelined using your data ops, and that will be automated using your AutoML engine. That is what I was about to tell you, right? So this is one of the good platform for a beginner and for an intermediate level. For a expertise level, right, you can build your own model, and you can, this particular engine has a provision for it, right? So now yeah, so it is asking me for some permission. So now what I'll do is I'll give access to my camera, right? Oh, my camera is not visible. Just a minute. I'll just rescan again. Go for deployment. Yeah. So now my camera is visible. If you look at here, okay, I'll just maximize my window. Can you able to see here? So how it is getting inferencing? So multi-class, right? So Ashirwad, AC remote, Serlac, line dates. See the probability, right? So now if I bring my AC remote, you can able to see the AC remote, right? So now I'll bring Serlac. So can you able to see the switch between the column? So now it is Serlac. When I bring my AC remote, now it's AC remote. Now it's AC remote. And if I bring back my line dates, and if I bring Ashirwad vermicelli, right? You can able to see the quick. Sorry. So you can go for multiple things. So this is the beauty of ML. So just a minute, I'll just leave the meeting. Right. So so this is how the AutoML execution pipeline went, right? So we prepared data, then we feature engineered, then we selected the feature, then we selected the appropriate machine learning model, then we set the parameter for our hyperparameter, right? So the data can be structured or unstructured, right? So it could be anything, right? So, and again, one part I just left it is I just forgot to show you the other end of data labeling part. Sorry for that, right? So now when you want to go for the other labeling part, right? So now that is also possible. So for that, what you have to do is you just switch between one label per data to bounding box. Once you click on bounding box, again you can go to data acquisition part, and you can just click on labeling queue. Once you click on the labeling queue, what you can do is you can create your own label. This also it's possible. You can create your own label, or else, sorry, or else you can just go for, there is an option using classify using YOLO V5. It's an auto labeling method. What happens was automatically it labels. Okay, so now if I save the label, it will go for next image. I'm not doing anything. I'm just making my mouse. Okay, there will be a false positive, so it's wrongly predicting as a cell phone. Okay, so if I want, I can just change it. It's not a cell phone, it's a remote. I can change it and I can instruct. I'll save it and I can go for next image. Yeah, again, it's a wrong labeling. I can, right? So this is how the auto labeling part works. You can automatically, you can label, or else if you want, you have a time, you can go for labeling with your own. That is also possible. And when you are labeling it, you can go for multiple labeling on the same image itself. That is also possible, right? So I hope I have given you a complete clear insight. And if you have a laws and other things, you can configure your Eon tuner and you can try it out as well, right? And once you configure your Eon training, then you can go for retraining your model. But these steps will take a lot of time. So that's the reason I'm not touching it. But I have given you the entire pipeline of how AutoML can be used and configured and utilized, right? So these are all some additional features, right? Once you are good enough with all these configuration, these two things will not disturb any of the things, right? So all you need is just you are going for a retraining it, and then you can go for versioning, model testing. That is also possible. These things you can do it on your own, right? So I think I am done with my presentation. Any doubts, or if you have any questions for me, I'm open for questions.